This is a talk about the new updated edition of my book, The Science Delusion. The same book is called Science Set Free in the United States, which is a bit confusing, but in Britain it's called The Science Delusion, Freeing the Spirit of Inquiry. The first edition came out in 2012, and quite a lot has happened since then. Developments in science have in many ways amplified the points I was making in the first edition of this book. What I'm going to do this evening is first summarize some of the basic points in the book for those of you who haven't seen the first edition, or for those of you who didn't see my TEDx talk on the subject, which was in 2013. And then I'm going to focus on some of the areas where the science has changed most in the last 8 years. In this book, what I do is take the 10 principal dogmas of mechanistic materialism, which is the dominant orthodoxy of the sciences today. In fact, it's the dominant orthodoxy of the educational system, government, business, and so on, practically everywhere in the world. It has 10 basic assumptions. These started out as working assumptions that scientists just use to simplify the field of inquiry, but they've hardened into dogmas. And these are absorbed by people in their scientific education, or even in their just general education, as if they're true. This is in fact a wildly eccentric belief system, but we've all been brought up with it to take it as if it's true. And most people assume it must be true because this is the basis of science, and science is immensely successful. Technologies particularly, and modern medicine, have transformed all our lives. We wouldn't be able to do what we're doing now. Me sitting in Hampstead, London, talking, you watching from your homes or other places all over the world without these amazing technologies. So people assume it must be true because it leads to all these astonishing results. Well, actually, the worldview, the metaphysical or philosophical framework of science could change, and all these technologies would still be there. They don't depend on this worldview. The mechanistic part of mechanistic materialism is definitely convenient for a machine-based civilization. And in fact, the first dogma is that nature is mechanistic or machine-like. This basically, it takes the idea of the machine as the central metaphor for nature and for science. This became the central metaphor in the 17th century when modern science as we know it was first established by people like Galileo, Descartes, Kepler, Newton. And these founding fathers of modern science all took the view that nature is mechanical, machine-like. The whole universe is a machine, animals and plants are machines, our bodies are machines. And they didn't prove that nature was like a machine. They used a metaphor and extended it to everything. Now, it's only a metaphor, and of course the machine metaphors have been updated. It was hydraulic machinery and in the 17th century, in the 18th century, the early water mills and things were important. In the 19th century, steam power and steam engines. In the 20th century, telephone exchanges, telegraphs, and so forth. And of course, in the 21st century, computers. The metaphors have been updated, but the basic idea has not. In the 17th century, most people took it for granted that the universe was an organism. Before this mechanistic revolution, the standard view of nature taught in the medieval universities under the influence of Aristotle and St. Thomas Aquinas was that nature is essentially organic. The earth is a living organism, Mother Earth. Animals and plants were beings with souls. That's why the word animal comes from the Latin word anima, meaning soul. We ourselves were linked to nature through the life of our bodies and the shaping of our bodies was similar to the growth of plants. We had a kind of vegetative soul that shaped our bodies. Our instincts and our senses worked in a very similar way to many other animals. We have an animal soul as well. And then in addition, an intellectual, rational soul concerned with reason, language, and so on. Well, this metaphor has now become completely baked in to our thinking. People say things like, what's the mechanism? We use these machine phrases all the time: genetic engineering, factory farming. But it's only a metaphor, and it's not obvious that it's the best one. It's very anthropocentric. Only modern humans make machines. So it really extrapolates our modern obsession with machinery onto the whole of nature. A much better metaphor, as I discuss in my book, is the organism. The universe is more like an organism that began with the Big Bang. It was like the hatching of the cosmic egg. We're more like organisms. Animals and plants are more like organisms. In fact, they are organisms. So to stick with this restrictive metaphor exclusively is very, very restricting to our thought and gives us a very distorted view of nature, which I think has a lot to do with our present ecological crisis. The second assumption is that the total amount of matter and energy is always the same. It all came into being in an instant at the moment of the Big Bang, and it's remained the same ever since. In the 17th century, it was assumed that God created all the atoms and the movement or energy in the universe, and because they were God created, they were permanent. And that's now been enshrined in the principles of conservation of matter and energy. And most of us learn this at school and think this must be true. But actually, sciences have moved on, and in physics, starting with astronomy in the 1980s, there's been a recognition that there's a huge amount of matter that we can't see and don't know its nature. It's called dark matter, introduced into physics in order to explain what normal gravitational theory wouldn't explain about the galaxies and the way in which they're organized. Then it turns out that the universe is not stopping or slowing down its expansion because of all this extra energy, matter, more than 5 times more than the known kinds of matter. The universe is expanding faster and faster. It's accelerating in its expansion. And so physicists have invented something called dark energy to try and explain that. The amount of dark matter and dark energy is now 95% of reality. So the regular matter and energy you learned about at school, and which we experience in our everyday lives, is only 1/20th of what's there, and we know nothing about the rest. Its nature is literally obscure. So if we say, well, the total amount of dark matter is always the same, or the total amount of dark energy, there's no possible way of knowing if that's true or not. And in fact, according to the most popular theory of dark energy, the amount is increasing as the universe expands. The total amount of energy within it increases, so the universe has become a perpetual motion machine. The third assumption is that the laws of nature are fixed. They're all supposed to have been fixed at the very moment of the Big Bang, like a kind of cosmic Napoleonic code, and they've remained the same ever since. But as I've shown in some of my other books, A New Science of Life and The Presence of the Past, and as I discuss more briefly in this one, it makes a lot more sense in an evolutionary universe to think of the laws of nature as more like habits. And indeed, I think they are habits maintained by a process I call morphic resonance. I think there's a memory in nature. Each species draws upon a kind of collective memory and contributes to it. The next assumption or dogma is that nature is purposeless. There's no point in anything. There's no point to evolution. It's just blind process driven by chance and the laws of nature that's not going anywhere. There's no purpose in our lives. There's no purpose in the whole universe. Now you might think, how do scientists know that? Well, they don't know that. They just assume it. And they assume it because of the machine metaphor. Machines don't have purposes of their own. They're there to serve our purposes. A car doesn't have a purpose to go to one place or another, from London to Bristol, say. It will go anywhere you want it to go. A horse, which is an organism, when you get on its back, may have its own ideas about where it wants to go. But a car doesn't, machines don't, unless we program them like guided missiles to have a particular goal or destination. But that, again, depends on us giving them their purposes. So if the universe is a machine, then it doesn't have any purposes of its own. It may have divine purposes if it's made by God, as in 17th century mechanistic theology. But it doesn't have any of its own, and nor do animals or plants, and nor ought we to have any purposes either. So the next assumption after that is that matter is unconscious. The whole universe is made of matter. That's what materialism says. Matter is the only reality, or sometimes people prefer to say physics or physical being is the only reality, in which case they call it physicalism instead of materialism, but it boils down to much the same thing. So the idea is the entire universe is unconscious. All the stars, all the galaxies, all the planets, all the gas clouds, and everything on Earth is supposed to be unconscious too, if all nature is unconscious. Now, scientists, as I say, never proved this. They assumed it. In the 17th century, René Descartes had a vision of the universe as a machine in 1619 and came up with the idea that the whole of nature is made up of unconscious matter. He didn't deny consciousness, but he thought it was excluded from nature. It was supernatural rather than natural, and existed within the being of God, in the angels and spirits, and in human minds. But it was radically separate from matter. So that created what's often called Cartesian dualism, a radical duality of matter and mind. And that dominated the sciences until the 19th century. It is still implicit in many people's thinking. But according to materialism, which became the dominant orthodoxy in science towards the end of the 19th century, there's no such thing as the realm of consciousness or spirit, no such thing as God or angels. This theory is intrinsically atheistic. It denies the existence of any forms of consciousness within or outside nature, except our own. We ought not to be conscious either, according to materialism. And in fact, a lot of Anglo-Saxon philosophers of mind have spent decades trying to prove that we're not conscious, or that if we are, our consciousness doesn't actually do anything. We don't have free will, can't make real choices. Consciousness is a kind of illusion, or it's just a way of talking about the activity of the brain, or it's a kind of meaningless epiphenomenon associated with the brain, like a kind of shadow that doesn't do anything. That is the state of play within the materialist theory of consciousness. Now, I'm going to come back to this idea of nature being unconscious, because this is one of the areas where thinking has moved on in the last few years. The next assumption is that biological inheritance is material. It's in the genes, primarily in the genes, or more recently in the epigenetic modifications of the genes. Again, I shall come back to that a little bit later. Then there's the assumption that memories are stored as material traces in brains. Scientists have spent decades trying to find these memory traces, and they've failed again and again. Whenever they think they've found them, they can find a bit of the brain that changes when a rat learns something. It then turns out if you cut out that bit of the brain a few days later, the rat can still remember. Then they say, well, there must be other backup memory stores somewhere else. This has been going on for a very long time, and I think these failures to find memory traces have happened because memories aren't stored in the brain at all. I think that we resonate with ourselves in the past. Bimorphic resonance, rather like TV sets pick up signals by resonance. I think our brains are more like TV receivers than like video recorders. I don't think the memories are stored inside them. I explain why in my book, and I also give an update on recent research on memory traces or supposed memory traces using very sophisticated techniques called optogenetics. The next assumption is that minds are inside brains. Your mind's inside your head. That's because it's produced by the physical material activity of your brain. Again, there's no evidence for that, but it's just taken for granted that that must be the case. And as I show, there's a lot of evidence that minds extend beyond brains, that our minds are more like fields that stretch out beyond our bodies and brains, just as the working of your mobile telephone depends on invisible fields that stretch out far beyond the phone, or the magnetic fields of a magnet stretch out far beyond the magnet, or the gravitational fields of the earth stretch out far beyond the earth. I think the fields of our minds stretch out far beyond our brains. Our minds are extended, not compressed, inside our skulls. So again, that's an assumption. The mind is in the brain. And from that follows the next assumption or dogma: psychic phenomena are illusory. If the mind is confined to the inside of the head, if it's all in the brain, then there's no way that you thinking of someone, wanting to call them on the telephone, could actually influence them hundreds of miles away. There's no way they could pick up your intention, start thinking about you, so that when you actually ring, they say, "That's funny, I was just thinking about you." Yet, this phenomenon of telephone telepathy is extremely common. More than 80% of the population have experienced it. I'll come back to this later. But materialists have to deny that psychic phenomena take place. It doesn't fit with their worldview. And so they're forced into a position of denial, just outright denial. These things are impossible. There's no evidence for them. They say they can't be reproduced, or if there is any evidence, it's all flaky or fraudulent. But they basically have to sweep away all the evidence of their own experience, that of their friends and family members, and a great deal of scientific evidence as well, in order to maintain this belief system. And the final one of the 10 dogmas is the dogma that mechanistic medicine is the only kind that really works. Alternative and complementary medicines, traditional Chinese medicine, acupuncture, herbal medicines, shamanic remedies, Ayurvedic medicine, naturopathy, homeopathy, chiropractic, all these things are just quack remedies made by, put out by people who are frauds, basically, or quacks or charlatans. The only kind of scientific medicine that exists is proper, regular medicine that treats the body as a machine, a physico-chemical machine that can be treated physically by surgery or chemically by drugs. And of course, surgery and drugs work. We've all benefited from them. There's no denying that, but is that all there is to medicine? From the point of view of mechanistic materialists, yes, that's all there is, and therefore no public funding, at least in Britain, should go to any alternative or complementary medicine, because we know in advance it's all quackery, and these things should be excluded as much as possible from the National Health Service, although they are creeping in at the margins, partly because they're much cheaper. Now, the final summary of those are the 10 dogmas, and then I have a chapter called Illusions of Objectivity, where I point out that scientists like to think they're much more objective than anybody else. And again, I'll come back to that, because that has now come severely unraveled through the reproducibility crisis, where it turns out that most scientific papers, even in the most eminent peer-reviewed journals, cannot be replicated. And this has thrown science into turmoil in the last few years. This crisis had not occurred when the first edition of the Science Delusion appeared, although I pointed out in that edition that it was very likely to happen, because this is simply the way things are going on. It was bound to lead to a reproducibility crisis. Well, now this is common knowledge. So that's a summary of the main points in the book, and the way I structure the argument, for those of you who haven't read the book, is I turn each dogma into a question and treat it as a scientific hypothesis that can be looked at in the light of evidence. So for the dogma, nature is mechanical, that chapter is called Is Nature Mechanical? For the dogma that minds are in brains, it becomes the question, are minds confined to brains? For the question, for the dogma, nature is purposeless, it becomes the question, is nature purposeless? And so on. Well, now, with that overview, I now want to turn attention to 2 or 3 of these dogmas in more detail. And what I want to start with is the idea that nature is unconscious, matter is unconscious, the whole universe is unconscious. As I said earlier, this is an assumption that was built into science, and in the 17th and 18th century and the first part of the 19th century, most people assumed there was a consciousness in the universe as well, the consciousness of God or of angels and spirits and of human minds that were not part of this unconscious matter. But materialism is precisely the doctrine that those such non-material forms of consciousness don't exist. And the only thing that exists is non-conscious matter that somehow mysteriously leads to consciousness in our own brains in a way that needs to be explained away. Well, this is called the hard problem in philosophy of mind, because trying to explain away consciousness is not very convincing. Every time a materialist philosopher comes up with a theory, other materialist philosophers show that it can't be true. So they come up with another one, and so on. This has been going on for years and years and years. Whole careers have been built on this in philosophy departments. For example, one theory that has been postulated in the last 20 years is the idea that consciousness is some kind of illusion produced by the brain. But the problem is that that doesn't explain consciousness, because illusion is itself a mode of consciousness. It presupposes consciousness. So then it's a question of back to the drawing board, and people come up with another materialist theory. Anyway, they all go on and churn around. But this has led to a number of philosophers despairing of ever solving the hard problem in terms of materialism. And this has led to a growth in the philosophy of panpsychism. Panpsychism means that there's a kind of mind, psyche, or soul everywhere. It is usually taken to mean that an electron, for example, has some low degree of mind, consciousness, purpose, or meaning, or experience. An atom would have more, a molecule would have more still, a cell would have much more than that, then a whole organism would have more. And so there'd be a difference of degree between our own consciousness and that of much simpler systems. So panpsychism was mainly put forward in order to try and solve the hard problem by saying it's not a difference in kind, which is incomprehensible. It's a difference in degree that separates our consciousness from that of much simpler systems. The British philosopher Galen Strawson was one who led the way in this way of thinking. A recent development is in the Philip Goff, another philosopher here in Britain, whose book Descartes' Error is a powerful statement of the arguments for panpsychism. Panpsychism is very similar to animism, the idea there's a kind of life and mind in nature. And animism is the worldview found all over the world. It's part of shamanic cultures. It was part of Christian culture in the Middle Ages. The Christian theology in the Middle Ages was essentially a kind of Christian animism. It's what you find in India, in China, it's in Africa. It's the traditional worldview practically everywhere. The the mechanistic materialist worldview is wildly eccentric in that context. It's a denial of what almost everyone everywhere has taken for granted, and what children take for granted until they're about 10 or 11. We fill our children's minds with stories of talking bears like Rupert Bear and Peter Rabbit and Winnie the Pooh and so on. They live in an animistic world. But then by the time they're 10 or 11, they're told, oh, well, that's childish nonsense. The world's really made up of machinery. Your body's a machine, your brain's a computer, and so on. So even our own children live in an animistic world. And some people think that the reason that grown-ups read children's novels so much, like Harry Potter or Philip Pullman's books, is because adult fiction can't easily portray an animistic world without being thought stupid or superstitious or silly. But children's books give permission for us to exercise our imagination in that particular way. So panpsychism is not a new idea, very far from it. But what's new is the fact that it's taken seriously within universities and philosophy departments now. It's growing in its influence as more and more people see that this is the best way forward. I think it's also growing in its influence because many people are having experiences, particularly with psychedelics, that convince them that we do live in a living world where mind is not just confined to the insides of human heads. The American writer Michael Pollan wrote a very interesting book that came out last year called How to Change Your Mind, about the new science of psychedelics. And Pollan described himself as a materialist and an atheist. But in the course of his research for the book, he felt he ought to try some of the psychedelics he was writing about. And when he did so, his mind was completely changed. The book's called How to Change Your Mind. And by the end of the book, he says that he used to think his mind was confined to the inside of his head, but now he thinks mind is much more widely distributed in nature, in trees, in the earth, in other species of animal, and so on. He'd undergone a kind of panpsychist revolution in his own thinking, a paradigm shift. And this, as I say, is actually happening in philosophy departments. Panpsychism has been part of the Western tradition in philosophy, in fact, for a long time. In the 17th century, in response to Descartes' gloomy material, the idea of matter as unconscious, there were two major panpsychist philosophers reacting to him. One was Leibniz, who said that nature is made up of self-organizing units called monads. And monads each of them has a kind of mind as well as a body. Each atom has a body and a mind, and each monad, or even an atom, can reflect the universe from its own point of view. So all monads everywhere in the universe are reflecting the whole universe, a whole series of points of view throughout the universe that are being reflected. That was a very fascinating view of Leibniz. And Spinoza, the Dutch Jewish philosopher in the 17th century, had a view of nature as the body of God and God as the mind of nature. It was a kind of panpsychism in which nature and consciousness were intermixed at all levels. The most interesting 20th century panpsychist philosopher was the British philosopher Alfred Whitehead, who was the first philosopher to put forward the idea of the philosophy of organism. We should see nature as made up of many levels of organisms rather than a machine. And he was also one of the first philosophers to recognize the importance of quantum theory. He was a mathematician as well as a philosopher, which is why he was able to get it straight away in the 1920s, that quantum theory changed everything. Because what quantum theory shows is that matter is not stuff. It's not substance that just stays the same, like little billiard balls. It's a process. Matter, electrons, protons, photons, which are particles of light, and all the particles of matter, like the particles in atomic nuclei and electrons, are processes. They're waves. As quantum theory says, that they're wave patterns, they're energy bound within fields. And if they're waves, they take time to wave. You can't have a wave at an instant, at a point, or at an instant in time. And so waves have to be spread out in time and space, which is why ultimately you have the uncertainty principle in quantum mechanics. You can't precisely localize material processes in space or time. You can only describe the probabilities of finding them in a particular place or time. So everything material, even an electron, is a process in time. And as Whitehead pointed out, that means it has a future pole and a past pole. There's a polarity in time between future and past. And he thought that this was the best way we have of trying to conceive of the relation between the mind and the body. The mind is the future pole, the body is the past pole. He pointed out that what minds do or conscious minds, is consider possibilities. Our minds contain many different possibilities that coexist within our minds. They're possibilities, not actualities. They're not physical, but they can affect the physical world when we choose among them. Every time we make a choice, we choose one possibility rather than another. All of us chose to be here now, me to give this talk, you to be watching it. And we could have done other things this evening. We could have been in other places, but we chose this particular thing out of the many possibilities, and we've done it. We're here. We can be photographed, measured, weighed. It's a physical fact that we've made this decision, and it's actually come true, and we can be measured physically, and this is an objective fact. But our minds are now opening to a whole series of new possibilities, and we're constantly concerned with choices among these possibilities, and that, Whitehead said, is the role of consciousness. Normally, people try and understand the relation of mind and body in spatial metaphors. The mind's inside, the body's and the external world is outside. We talk about the inner life and so on. But I think Whitehead's model of temporal polarity makes a great deal more sense and enables us to make sense of our own experiences. It's even true for an electron. If you describe an electron, what's going to happen to an electron in quantum theory, you have Schrödinger's wave equation, and the wave equation tells you all the possible things that electron can do. It gives you a realm of possibility. And yet, those possibilities are not physical facts. They're part of physics, but they're not physical. They're possibilities. As soon as the electron interacts with something like a measuring apparatus or an atom, then those possibilities collapse down. It's sometimes called the collapse of the wave function, and it now becomes a measurable fact, but it's in the past. And so I think that this interplay of possibility and measurable fact that Whitehead was alluding to is perhaps the most promising way forward. Well, I discuss this in more detail in my book. Now I want to turn to the question of biological inheritance. The usual assumption is that biological inheritance is explained by genes, it's genetic. And very often people use the word genetic and hereditary as synonyms, as if there's nothing more to genetics than the inheritance than genetics. And genes became enormously important in the 1960s and 70s. They were the ultimate dream for materialists. They suggested that you could reduce all the properties of life to molecules. And materialism, as we know it, is very reductionist. It takes the view that the smallest things are the best or the most real. So if you can explain everything in terms of atoms or subatomic particles, then that's the solid foundation for the rest of science. And that's why billions of euros are spent on the Large Hadron Collider and they're now trying to spend billions more on an even bigger one. And in biology, this approach meant that the most prestigious kind of biology was molecular biology, because molecules are the smallest things. And so genes seem to provide the key to understanding life in terms of molecules, the ultimate reductionist materialist dream. And then evolutionary theory, in the neo-Darwinian theory of evolution, was formulated so that evolution became not a matter of phenotypes, plants and animals as we know them, but a competition between genes inside those phenotypes, which were merely carrying mechanisms for the genes. And this whole view was epitomized most clearly at the most popular level by Richard Dawkins' book, The Selfish Gene, a totally gene-centered view of life and evolution. The problem is that Dawkins is very good with metaphors, and he gets swept along with his own metaphors. And he actually endows these genes with life, purpose, meaning. They're ruthless, they're competitive, they're like Chicago gangsters, they can shape organisms, they make us lumbering robots to carry them around and to spread them in the world. So this gene-centered view and gene-centered theory of evolution led to extreme obsession with genes, and culminating in the Human Genome Project, initiated in the 1980s. The first draft was published in the year 2000. It was an enormous technical triumph, but a huge amount of money, time, and effort was invested in it, because people thought that if they know the whole human genome, it would be reading the book of life. The whole of human nature would be laid bare in molecular terms, and this would lead to a whole new era of medicine and so forth. Well, it's been downhill all the way since then, because the first shock was that instead of about 100,000 genes, we only have about 20,000, less than a sea urchin and less than half the number of a rice plant. So there's not, that was a big shock. People expected far more genes. Then they expected that you could patent them and make lots of money out of them. And that again hasn't happened. The biotech industry in the slump of 2001 more or less collapsed. A lot of these biotech companies that were going to make fortunes out of genes went bankrupt. It turned out not to be so useful after all. And then people sequenced tens of thousands, hundreds of thousands of people, and compared the genomes of lots of people to work out the genetic basis for various characteristics, including height. It turns out that the genes, there are about 50 of them involved in the control of height genetically, explain only about 10%. Some would like to claim it's as much as 20%, but that's controversial, of the inheritance of height. That leaves the rest of it unexplained. People also thought you'd be able to give diagnostics of breast cancer and liability to all sorts of other diseases, Alzheimer's, schizophrenia, in terms of genes, but the predictive power turns out to be very low. In most cases, not more than 10%. So instead of explaining 100% of inheritance, genes explain for most important characteristics only a minority of the inheritance. And this is now called the missing heritability problem. Now, genes most convincingly explain rare genetic conditions like cystic fibrosis or sickle cell anemia, where there's a defect caused by one defective gene. But the great majority of health problems are very, very much more complex. Many genes are involved, and there's another aspect to inheritance that genes completely leave out. Well, I would say there are more than one aspect that they leave out. The one aspect that's attracted a great deal of attention in recent years, and which I summarize in this updated edition of my book, is the epigenetic revolution. In the 20th century, it was considered heretical to suggest that organisms could inherit characteristics that their parents had acquired. The inheritance of acquired characters was a completely taboo topic. at least in the West. It was the normal view in Soviet Russia up until the 1960s. But the very fact that it was politically polarized made things worse. However, since the year 2000, it's become recognized that there are indeed acquired characteristics that can be inherited. The whole subject has been rebranded Epigenetic Inheritance and is now one of the most exciting areas of biology. It turns out that all sorts of characteristics can be inherited by animals and plants and people. For example, the small thale-cress plant Arabidopsis, which is the model organism that many plant scientists work on, can be grown in heat conditions, under unusually hot conditions. And the seeds from those plants, when planted out, will give a next generation which is more heat tolerant than control plants grown under normal conditions. There's been an inheritance of heat tolerance. The nematode worm, Caenorhabditis elegans, which is again a model organism widely used by many animal researchers, can be trained to wriggle towards food, which is scented with a synthetic chemical called benzaldehyde. And if you do this for one generation, then the offspring of those worms are still attracted to benzaldehyde, but it fades away over a few more generations. If you do it for 4 generations of worms associate the smell of benzaldehyde with food, then for at least 20 more generations, they go on being attracted to benzaldehyde. This has nothing to do with a genetic mutation. This is an inheritance, an epigenetic inheritance of an acquired character. And there are molecular forms of epigenetics whereby genes are silenced, switched on or off as a result of epigenetic processes, and this switching on or off of genes in some cases can be inherited. So we're not talking about mutations, we're talking about something quite different over and above the regular form of genetic inheritance. In tomato plants, if they've been attacked by caterpillars, their offspring are more insect resistant. They inherit an ability to create chemicals within the plant that give them protection against caterpillar attacks. And one of the more dramatic experiments of this kind concerns mice. In a paper published in Nature, the leading scientific journal, there was a discussion of this phenomenon called inheriting the fears of fathers. In these experiments, the scientists trained mice to become averse to a particular smell, in this case, acetophenone, a synthetic chemical. Whenever they smelt it, they were given an electric shock through their pores. This was a classic, rather cruel, conditioned reflex type conditioning. Well, after a few of these experiences, as soon as the mice smelt acetophenone, they froze with fear. That's what mice do as a fear response, they freeze. They then bred from these male mice that had been made averse to acetophenone with females that had not had no exposure to acetophenone, and they took the males away after the breeding had taken place. And the children and the grandchildren of those mice froze instantly as soon as they smelled acetophenone. They'd inherited the fear of their fathers. Some people thought, well, maybe this is because the male mice told the female mice about it somehow or communicated information about this experience. So they then redid the experiment using artificial insemination, so the mothers never met the fathers. And the same inheritance effects occurred. Now, you see, this is very fascinating, and it changes our view of evolution. There's now a ferment in evolutionary theory, again, I describe this in my book, called the extended evolutionary synthesis. Old-style neo-Darwinism was all about genes and gene frequencies. It had a kind of tunnel vision, just this single aspect of inheritance and evolution. And the entire edifice of neo-Darwinism is based on this assumption. Well, now it turns out that evolution can happen much quicker. If you wanted to make mice to be afraid of acetophenone under neo-Darwinism, then what would have to happen is a random mutation that meant some mice would be frightened of acetophenone. When they were exposed to it, this would give them some advantage in avoiding this dangerous substance. And they would breed more than other mice. And over many generations, this gene would become more frequent in the population. But it would take many generations for this to evolve. And it would be random and purposeless and just chance that it showed up in the first place. But if mice can inherit a learned response, then in a single generation, you can have an evolutionary upgrade. If organisms can respond to new environments, for example, migrating birds may be blown by the wind off course to a new environment. If they can adapt to that new environment, their offspring can, and if their offspring can inherit those adaptations, you have immediate evolution, which has a much greater role for purposive creativity on the part of organisms. This changes completely our view of evolution, and in the so-called extended evolutionary synthesis, genes are part of evolution, but they're not the only part or even the most important part. Many other factors play a role, including epigenetic inheritance. And I think that even beyond epigenetic inheritance, there's another form of inheritance through morphic resonance. I mentioned at the beginning, this is a principle of memory in nature, is based on similarity. And this makes testable predictions. If you train rats to learn a new trick in London, rats all over the world, in Melbourne, Australia, in New York, in Paris, should be able to learn the same trick quicker just because the rats have learned it here. They should pick up by morphic resonance something that the rats here have learned. Now, there's already evidence from laboratory experiments that this actually happens, surprisingly enough. If it only happened to rats that were descended from the trained rats, then you could think this is an epigenetic inheritance that involves modifying genes in some way, or masking or unmasking genes in some way. But it actually happens in all rats of that breed. It's not confined to ones that are whose parents have been trained. And so I think that an even more extended evolutionary synthesis has to take into account morphic resonance as well as epigenetic inheritance and genetics, and of course cultural inheritance, which also plays a major role in evolution. So that is an area of biology that's very exciting at the moment and where there's a lot of discussion and activity. Now I want to turn to psychic phenomena. The evidence for parapsychology is surprisingly strong. So-called skeptics, they're really dogmatic skeptics or pseudo-skeptics, people who are materialists who believe these phenomena are impossible, are forced to deny all this evidence. And they usually say things like, there is no evidence, or never been any replicated experiments, or it's all been shown to be fraudulent, or only stupid people believe that, or they just simply deny it. There is no evidence. Well, there's actually a large amount of evidence, and one of the most replicated experiments in psychology is the so-called Ganzfeld telepathy test done in parapsychology laboratories. It's been going on for decades, and a meta-analysis shows these findings are very robust. It's replicable. It's happened over and over again by many different researchers in different labs. There's a lot of evidence now for the sense of being stared at, a subject I've investigated myself. There's really good evidence now that people can tell when they're being looked at from behind, even if it's in a random sequence, and even when they can't know by any other means, when they're looked at through one-way mirrors or windows or closed windows, or even through closed-circuit television. There's very good evidence now for telephone telepathy, the phenomenon whereby you think of someone who rings, or you just know who it is before you look at the caller ID, or answer the phone. I've done a lot of this research myself. It's been replicated in the University of Amsterdam in Holland and Freiburg University in Germany. And I have an online telephone telepathy test that anyone in Britain or the US or Canada can try for themselves on mobile phones. If you go to my website, sheldrake.org, and go to the Take Part or Participate section, you can log on. It's fun to do. And in my basic experiments on telephone telepathy, people who say it happens to them fairly frequently nominate callers who it might happen with. In the first experiments, we had 4 callers. We would pick one at random, ask them to phone their friend. The subject was filmed with a landline with no caller ID, no other computers or phones in the room. When the phone rang, they had to guess who it is. I think it's John. Pick it up. Hello, John. They're right or wrong. They'd be right 25% of the time on average by chance. In fact, in these filmed experiments with hundreds of trials, the hit rate was 45%, very significant statistically, odds against chance of billions to 1. And then there's a lot of evidence that nursing mothers are telepathic with their babies. Again, you can read about these experiments in my book, The Sense of Being Stared At, and other aspects of the extended mind. Well, how do skeptics react to this, the pseudo-skeptics? Well, in their usual way, by denial. Last year, in 2019, a meta-analysis of many different experiments in psychic research and parapsychology was published in a leading magazine, The American Psychologist. It was a very convincing overview of a great deal of evidence. The American Psychologist magazine then printed a few months ago a rebuttal by one of the leading skeptics in America, a member of the Committee for Skeptical Inquiry, one of the main skeptical activism advocacy organizations, someone called James Alcock. And James Alcock and a colleague of his wrote in their paper, we don't need to look at the evidence for these psychic phenomena because we know they're impossible. So it's absolutely unnecessary to take any of this evidence into account because the phenomena simply cannot possibly happen. Therefore, all the evidence must be flawed or fraudulent. And this is more or less the state of the art in current day scientific skepticism, or so-called scientific skepticism. Unfortunately, people with this worldview have captured all sections of Wikipedia dealing with parapsychology, alternative medicine, and they've captured the biography pages of people like me who do research in these taboo areas and distorted them hopelessly. All attempts so far to put a more fair picture onto Wikipedia have failed. There are groups of highly motivated activist editors who've simply taken control. So the arguments for parapsychology, for the reality of psychic phenomena, are strong, and the idea that these are illusory is simply a product of dogmatic denial by mechanists. You don't have to take my word for it. You can read the literature yourself, and all my own papers on this subject are on my website in PDF form from scientific journals, free of charge. Now, finally, I just want to turn to the assumption that science is uniquely objective. Scientists used to write their reports, some still do, in the passive voice, a test tube was taken, to make it sound as if they were just observing nature unfold in front of them, that they were completely objective. And instead of saying, I think, they'd write things like, it is considered that, as if some disembodied mind does the considering. Well, this pretense of unique objectivity and truth of science was very convenient for scientists who wanted to establish themselves as a kind of priesthood superior to actual priesthoods or all other kinds of human activity. Unfortunately, whether scientists are human, well, fortunately, scientists are human like everyone else and are motivated by personal ambition, rivalries, desire to get ahead, desire to get grants, promotion, and so forth. And there's every incentive for scientists to publish their very best results in scientific journals. Most scientists only publish 5 or 10% of their data. And obviously they select the data that looks best and shows them in the best light. If you only had to send in 10% of your tax data to the income tax authorities, you could make it look almost like anything you wanted. And then scientists have said, oh, well, science is objective because it's all replicable. Well, the fact is that most science is never replicated because until recently, most scientific journals would not publish replications. They said it's not original, and people wouldn't get brownie points for doing replications. If you found something couldn't be replicated, you just got into trouble. No one believed you. Well, things have changed enormously because in recent years, there's been this replication crisis that blew up after the first edition of this book was published. And systematic studies in biomedicine, in psychology, and in many other branches of science have shown that up to 90% of papers in highly prestigious journals simply can't be replicated. It's not necessarily because they're fraudulent. Sometimes they are fraudulent. And indeed, there's much more fraud in science than people have previously suspected. But mostly this happens for reasons that are all too understandable. People publish their best results. It's in the interests of scientific journals and their universities to talk up these results. No one wants messy, ambiguous results that don't really mean anything. They want spectacular results that they can claim would help cure cancer or revolutionize agriculture or genetically modify crops to resist drought or whatever. There's lots of incentives to overhype scientific papers and very little incentive to replicate them. People who do try replicating them often find that journal editors and scientific authors just don't want to know that they haven't been able to replicate a particular paper. It is much easier to ignore this. But this has all blown up into a massive scandal within science now. And you can read the latest findings in the new edition of my book. Now, finally, I just want to say that at the end of each chapter in this book, I have 4 questions for materialists. And I've just started a new YouTube and social media series where I'm giving short talks, 2 or 3-minute talks on some of these questions. These are real questions. And if you have materialist friends or colleagues, or if you're a materialist yourself, these are questions which really make it important to focus on what you really believe or what the materialists really believe. For example, in the chapter on nature, is nature mechanical? One of the questions from materialists is the machine theory a metaphor, or is it a testable scientific hypothesis? If it's a metaphor, why is it a better metaphor than the metaphor of the organism? If it's a testable scientific hypothesis, how can it be tested or refuted? Now, these are real questions. And for a materialist who believes that the total amount of matter and energy is always the same, one of the questions for them is the total amount of dark matter always the same? Well, they can't possibly say yes, because nobody in physics has a clue. They're forced, really, into saying they don't know. And that's my aim here, not to say that the answers are already known. They're not. The point is that we know so little about the nature of nature, whereas the mechanistic materialist worldview pretends that we already know the basic outlines of answers to all the questions about nature. These dogmas are the answers, and science is just about filling in the details. I don't think it's that at all. I think we're on the threshold of a whole new phase of scientific discovery and exploration. And when we move beyond these dogmas which restrict scientific inquiry, I think science will undergo a renaissance. I think it will become much more fun, much more interesting, and probably a lot cheaper as well. Thank you.